So today we're using a process for solving quadratic equations called completing the square. The easiest way to picture this is using geometry, using shapes. So suppose we have a rectangle that's x units high. Now, if it's wider than it is high, okay, like this one is, then we know that part of the length can be made up with x, right? And the other part would be some missing piece, some extra portion. So let's first make this kind of a square here. There we go. Close. X by x square. And then this is the extra piece over here. Right? So far, so good? Now, what I want to do is I want to turn this into a square. Okay? Here's the problem. When I cut off part of this, okay, what I'm going to do is I'm going to cut off half of this. Okay? And I'm going to paste it down here. Okay? So this piece here is going to disappear and move down there. Now, as I said, I cut off half of it. So if it was b units wide, what's the width now? No, this is x. If it was b units wide, what is it now? Half of b. Okay? So this is now half of b. And that makes this the other half of b. Right? Now, as you see, in order for this to be a square, I'm missing a piece, right? Down here, I'm missing this piece. Now, originally, my area was x by x plus b. That's what the area was to begin with, right? It was x tall, x plus b wide, which gave me a total area of x squared plus bx. So far, so good? That's what it started at. Okay? Now, I've still got x here, or x squared here, sorry. That's an x by x section. This is x squared. What's the area of this rectangle? Half b.
B squared.
No, not b squared. This
Half bx.
half of b times x. Okay, because it's half of b wide times x units high. And what about this portion down here? Same thing. Half of b times x. So far, I've got x squared plus half of bx plus half of bx. And then I got to throw in some missing piece. We'll get there in just a second. Okay, there's our missing piece that we're going to throw in. Now, what's half of bx plus half of bx? A full bx.
Squared? Would it be squared?
No, not squared, because we're adding, so we don't combine our exponents. So the question is, what does this missing piece have to be? Well, look at it. What's going to be the area of that square?
Half of b. Half of b squared.
Half of b squared. Because it's half of b. This is half of b, right? And this is half of b. So its area is that half of b times half of b. Or half of b squared. Make sense?
Yes.
That's going to be our missing piece that's going to complete our square.
That makes so much sense.
Does that make sense? So what we're going to do is we're going to find that missing piece that's going to allow us to factor this, because if you think about it, the total area of this new square is what we have at the bottom, x squared plus bx plus b over 2 squared, right?
Yes.
We just found it by adding up the separate pieces. But another way of looking at the area of the square is that it's x plus b over 2 wide times x plus b over 2 high, or x plus b over 2 squared.
Oh, that's so much sense.
Right? Our width up here, remember that b got cut out and became b over 2, and we attach b over 2 here. So our width from here to here is x plus b over 2. And our length from here to here is x plus b over 2. So our area is x plus b over 2 times x plus b over 2, which is this right here. Right? But if we look at it as individual pieces, we have the top left-hand corner, which is x squared, and the top right and the bottom left together make bx, and the portion that we're adding in to fill it is b over 2 squared. So what we're going to be looking for today is how to find that missing piece, and this is our pattern. It's always going to be b over 2 squared. That's what you need to remember, b over 2 squared. That's the key. So example 1 asks me to find a value for c that will make this expression a perfect square. In other words, it will allow me to write it like this.
It's like solving a Punnett square almost.
Not quite, but close. So if we go back, everybody got this written down?
Yep.
If we go back to our diagram, what's our b? 5. Right? So we've got x plus 5 over 2. Okay? And over here we got x plus 5 over 2. So what's going to go in this missing box right here? 5 over 2 squared. That's the missing piece. So if we look at our expression, x squared plus 5x plus c, what's b? And this right here, what's b? 5. So all we have to do to fill in c is do 5 over 2 squared. What is it? What's 5 over 2 squared? Don't use your calculator. 25 over 4. So that's the value for c that will make it a perfect square. The question is, what's it a perfect square of? Well, it's really simple, because we fill this space in with b over 2, which is what? What's b over 2 in this case?
5 over 2.
5 over 2.
So on the x, in parentheses, x plus 5 over 2 squared, to move it to get to the 5 over 2 squared, you just have to just drop the x?
No. What we do is we see that when we multiply this out, if I take x plus 5 over 2 squared, that's the same as x plus 5 over 2 times x plus 5 over 2. Right? That's what it means to square. You multiply it by itself. So if I were to FOIL that out, I would be doing x times x, which is x squared. Right? X times 5 over 2, which is 5 over 2 x. 5 over 2 times x, which is 5 over 2 x. And 5 over 2 times 5 over 2, which is 5 over 2 squared. Right? So what happens when I add 5 over 2, x plus 5 over 2x?
It would be
Positive 5x. Right? So that's what I started with, and that c that I was missing is the 5 over 2 squared, which was 25 over 4. Okay. So what we're looking for is we're looking for this piece right here. And again, we always find it by taking our b, the coefficient of x, dividing by 2, and squaring it. That's always what goes there. So the first half of our answer that they asked for was what value of c will make it a perfect square. That was the 25 over 4 here. Then they want us to write the expression as the square of a binomial. That's this piece right here. The square of a binomial. 2 terms. Make sense? Now, let's put this in an equation. We can use this method to solve a quadratic equation. Now, when we were solving these before, our first step was to move 15 to the other side and factor, which is still, in some cases, a viable option. It will work if you have a factorable polynomial. But completing the square will work even if you don't. So when we're completing a square, we actually want to leave it just like this. We take our constant term, the term without an x, and we put it separate from the other terms, just like it's written here. All right, everybody good with the start?
Yes.
So our first step is to find, like we did in that last problem, that c value, that missing piece here that will make the left-hand side a perfect square. So what do we need to fill this spot with? We drop the x, we just need the b, which is negative 16, over 2, but then you're missing a piece. Squared. What does that equal?
8. 64.
64. Here's the problem. Am I allowed to just add 64 to one side of the equation? What do I have to do? I have to do it to the other side of the equation too. If I add 64 on the left, which I just did, I got to add it on the right. Okay, that keeps my equation balanced. Everybody okay with that? Now, I know the right-hand side adds up to 49. That's the easy part. I've got to factor the left-hand side. Now, if we did it right, it should always factor into a square. Can anybody tell me what goes in the parentheses? Isaiah?
-8.
That's part of it, but I need the whole expression.
X minus -8. Negative plus 8. Wait, no. Minus 8.
X minus 8. Okay? That sign there, this sign, will always match this sign. Okay? It just got factored. Think about it. What factors of positive 64 add up to negative 16? Negative 8 and negative 8. And so it would factor into x minus 8 times x minus 8, which is equal to x minus 8 squared. Okay? So what we're doing is we're using that b over 2 squared to find our missing piece, and then we're factoring it down to that square. Make sense? Now this line, this last line here, should look like what we did yesterday. What's our next step for solving that? Yes?
Take the square root of the radical 49.
Okay, we got to take the square root of both sides, right?
Yeah.
Cancels out the square on the left.
X minus 8 equals 7.
You're half right.
Plus -7.
Positive or negative 7. Right? Because 49 has 2 square roots. Positive 7 and negative 7. Then what do?
You would do 8 plus 7,
Mm-hmm.
and then that would be 15, and then you would do 8 minus 7, that would be 1.
Right, because we're adding 8 to both sides. So we've got 8 plus 7 and 8 minus 7.
So we have 2 answers.
So we have 2 answers. Make sense?
Will there ever be, like, when you do factor it, will there ever be, like, 2 different ones? That'll add, both of them add up together?
No. When we're completing the square, it's always a square. It's always the same thing that you're adding to both sides. All right, let me give you another one to do. Let's try. This one will have some decimals in it. Yep. So we're going to pause the video, give you a chance to try it, and then we'll go over it together. What was our first step? Yeah. Okay, so that's going to fill in our missing spot, right? So we divide 10 by 2 and square it, we get 25. So we add 25 on both sides, all right? What do we get on the right-hand side? 17. And what does the left-hand side factor into? M plus 5 squared. Okay? I think everybody got about to here, right? Except for we had a little trouble getting the 17 properly. Everybody good now? Yeah? So then we take the square root of both sides, right? We get m plus 5 on the left is equal to plus or minus the square root of 17. Right? Then what do we do? Subtract 5 from both sides. So we got negative 5 plus or minus the square root of 17, which is the same as negative 5 plus radical 17 and negative 5 minus radical 17. Right? So we need to make this distinction so that when we plug it into our calculator, we get the right signs out. So what's negative 5 plus radical 17? Yes? Negative 0.88 for this one. What's the other one? Yes? Negative 9.12. Okay.
How did you get the negative 5?
Because this was m plus 5, so to move it to the other side, I have to subtract it. You know that. You've done that in regular. You've done that before we did squares and stuff. Okay, to get rid of a plus 5, we have to subtract 5 from both sides. Does that make sense? Everybody good? All right, that's what the homework problems are going to look like. Okay, so the hardest part is keeping track of your signs and making sure that you've got the right signs in the right place. Any questions? All right.